Hai semua. Okey, kita sambung lagi. Topik still dalam topik 6. So in this video, we'll be looking at parallel reactions and how to maximize the desired product. So in this specific video, I'm going to show you on how to maximize desired product. But the parallel reactions involve only one reactant, meaning that one reactant is only reactant A. So for example, this A produce product B, A produce product B, and A produce product C. And for example, A produce product B is the desired reaction, A produce product C is the undesired reaction. So the stoichiometric coefficient, for example, for the coefficient for A may be alpha D, and coefficient for undesired one is alpha U. Rate constant is Kd. Undesired reaction, the rate constant is Ku. Therefore, the reaction rate for desired reaction, if with respect to reactant A, is negative Ra. But if it is based on product, let's say Rd, so meaning that this is the same as Kd Ca alpha D. So for example, we assume that this is elementary reaction. So the same as this thing. Ra undesired, so Ru, Ku, Ca alpha undesired. Right. Just to show that for this one reactant, if the question asks you what is Ra net, so meaning that it's the same as Rd plus Ru. So meaning that you have Kd Ca alpha D plus K undesired Ca alpha undesired. Okay. But for the specific topic in this video is to maximize the desired product based on selectivity. So in previous lecture, selectivity, the instantaneous selectivity, its definition is rate of reaction desired product divided by rate reaction of undesired product. Okay, therefore you have to divide the rate reaction of desired of this one, Kd, K desired Ca alpha D over K undesired Ca alpha U. And when you simplify, you'll get as Kd over Ku, Ca alpha D minus alpha U. Okay, and for this one, it shows Ca to the power of A, in which A dia letak dalam bentuk alpha D minus alpha U. Okay, so the selectivity, meaning that Rd over Ru, and when you simplify, you get Kd over Ku, Ca alpha D minus alpha U. So you have this selectivity. In order to maximize, we have to look at first case. the first case, if alpha D is bigger, the value is higher than alpha undesired. So bermaksud contoh kalau alpha D ni 2, alpha U ni 1. So quantity dia lebih besar. The value, bukan quantity, value. If alpha desired is higher than alpha U, meaning that kalau alpha desired minus tolak alpha U, of course it is bigger than 0. Okay, if this is the case, because you want to make sure that your desired product to be maximized in terms of selectivity, so meaning that your concentration has to be high, meaning that the Ca alpha D has to be maintained high compared to the Ca alpha U, because sebab dari segi ni, in order for you the selectivity to be high, so meaning that you have to make sure that Ca alpha D pun kena tinggi, and you have to keep the Ca alpha U to be low as possible. Betul? Sebab kita nak selectivity ni tinggi. Betul tak? Kan? Okay. So, in order for you to make this concentration of reactant A as high as possible, there are things that needs to be done. So these are the suggested things in order for you to make sure the concentration Ca is always high. So, antara cadangannya adalah gas phase reactions. You need, if the reaction use the gas phase, you need to make sure there are no inerts, and you always have to maintain high pressure. Kalau you maintain high pressure, so concentration akan sentiasa tinggi. So kalau liquid phase reactions, you have to make sure that the diluents of the concentration of reactant is always to be kept minimum as well. Kemudian you always in order to accomplish this also, the type of reactor also plays a role. So it's good to use the batch of flood flow reactors, because these reactors that always can maintain the high concentration of reactant A. And CSTR is not recommended to be chosen in this reaction in order to make sure the concentration of reactant A to be high. Okay, let's have a look at next case. The next case is if alpha of desired, the value is lower than alpha undesired. Means order of desired is low than undesired. So contoh, desired is 1 order dia, tapi undesired order dia 3. Contoh, okay. So kalau if this is the case, tadi you dapat you punya selectivity Ca alpha D minus alpha U, kan? But in this case, alpha D minus alpha U is less than 0. Bermakna sebenarnya Kd over Ku ni adalah uh, less than 0, so bermakna Ca berada di bawah. Kenapa? Bagi contoh, katalah tadi saya kata order for desired is 1, order for undesired is 3. So kalau you operate this term, dia adalah Ca negatif 2, betul tak? So bermakna Ca ni berada di bahagian bawah, denominator kan. So in this case, in order for you to maintain the high selectivity, you have to make sure that the denominator concentration ni is to be low as possible in order the selectivity to be high. Okay, concentration of reactant ni. Jadi, for this thing to happen, so you nak make sure Ca ni concentration dia very low. So dia adalah opposite from the first case. So gas phase reactions has to operate at low pressures. Liquid phase reactions, you need to use, you have to make sure the reactant A to dilute it as much as possible. Okay, you have to use the dilutant. And then the CSTR is preferred compared to batch or plug flow reactor. Okay, let's have a look at the next case in which kalau alpha D adalah sama dengan alpha U. Contoh order D adalah 1, order untuk U pun undesired adalah 1. So bermakna if this is the case, dia sama kan. So bermakna alpha D tolak alpha U equals to 0. So this term bersamaan dengan kosong. If that's happen, meaning that Kd over Ku Ca to the power of 0, meaning that Kd over Ku only. Betul? The selectivity. So if this is the case, dia tinggal rate constant saja. This is where you have to use the Arrhenius punya term pula. Okay, so Kd over Ku. So ni Arrhenius punya equation, desired, and then the activation energy also based on desired over RT. So bila kemudian yang ni undesired and activation energy of undesired. So ini dia. Okay, this is where it is. Bila you simplify, dia akan jadi macam ni. So bermakna kalau in order for you to ensure that the selectivity to be high, you have to deal with temperature for this case. Dari segi ni alpha D equals to alpha U, dia dah tak guna reactant lagi. Dia just kena guna in terms of activation energy and also temperature. Jadi for this case, if ED lebih besar EU, meaning that you have to make sure ni tadi macam ni kan. Okay, so you guna AD over EU, lepas tu ada in terms of exponential apa tadi tak ingat dah. Exponential activation energy. Okay. So exponential negative ED minus EU by over RT. But if this is the case, ED lebih besar daripada EU, in order to maintain high selectivity, you have to operate the reactor at highest temperature possible. And if activation energy of undesired is ataupun activation of desired is less than EU, so meaning that in order to maintain the high SD, the selectivity, you have to make sure that the temperature has to be lowest possible. It's related to the exothermic and endothermic punya condition actually. Alright. Till then, we continue with the next video.